Okay, so quick review from last day. Anyone remember what we learned on, was it Friday last week? What was that? Okay, so we learned a formula. What's the formula? Okay, so momentum, what's the letter for momentum? Little p. Capital P is power. I know, it's so tricky to keep track of. Little p is considered momentum, and it's a mass times the velocity. The units for this, by the way, there's nothing special about them. It's just kilograms, meters per second. Like, they don't have like a Newton or a joule or something special for it. I don't know why they don't actually. Oh, okay. I just noticed that there. So that's momentum. Let's say you want to change an object's momentum. Like, say it's a car. A car is going really fast and you want to slow it down. How do you slow down a car? Well, you need a force. Does that make sense? On a car, that force is probably going to be the force of friction. Okay. One more thing though, if you want to change an object's momentum, you don't just need a force, you need to apply that force over, I have it written here. Thought I had it written here. Let's change this here. Unless an external force acts on the object over a period of time. You guys remember this part then? If you have mass times change in velocity, that's equal to a force times a change in time. So if you want to change an object's momentum, you need a force, and you have to apply it for a certain amount of time. The longer you apply the force, the more you would change the momentum. Does that make sense? So if I had a force, but I only applied it for like 0.01 of a second, that might really not slow the thing down all that much. Okay. Here I've got some picture examples of different types of forces and how you can either stop or slow down, or this one's the really key one, I think, sending an object in the other direction. Okay. Like here's two rams hitting each other. I imagine as they come to hitting each other, the force of each other will cause them to probably stop, right, if it's around equal. Whereas like a baseball or a tennis ball, the impulse is going to be so strong that it's going to take momentum from being this way and actually changing it to go the other way entirely. Does that make sense? Could you grab the door, please? Thanks. So, today we're going to talk about probably the biggest application of momentum, which is about collisions. And I'm probably going to cover almost all of the Physics 30 curriculum on this topic actually in one day. I think I can get to all of it, which is kind of crazy, but we'll see. So, quick review before I get to that. Do you guys remember the term isolated systems? So there's three kinds of systems in case you forgot. An open, closed, and isolated. So I found another picture just to help make sense. Open system, mass and energy is able to freely come inside. So to me that's like the classroom. You guys can walk inside, the doors are open, so that's fine. And then a closed system is where matter can't leave but energy can leave. So that would be like if I closed all the doors to the classroom and I locked you in, physically you couldn't leave. Okay, so that's a closed system. Isolated systems are pretty much theoretically impossible to create an isolated system because that would be a system where even energy can't leave. Okay. Chances are though some amount of energy is going to leave the system, due to like, I don't know, sound or light or heat or friction or something like that. Kind of cool. Anyways, here's the key I need you guys to know. Just like with mass and energy, you guys have heard of like the law of conservation of energy, hopefully. The law of conservation of mass. Well, there's a law of conservation of momentum. So long story short, whatever momentum you start with should be the momentum you finish with if it's an isolated system. Make sense? So, two more thoughts. Momentum's a vector, so you have to consider direction. Oh yeah, question for you then. Take a look at this cannon here. Why is there a rope attached to the back? Anybody know?
It doesn't fly across the chest.
Exactly. According to a law of conservation of momentum, if I shoot a cannonball that way, that's a lot of momentum going that way, right? Well, there has to be momentum going back the other way to compensate for it, right? So what happens to the cannon? Well, the cannon itself fires right back at you, right? And so you gotta be quite careful. I believe like old historical ships, they used to put the cannons on like rollers so the cannon could actually rock backwards quite violently, and they'd attach a big heavy rope to it so the cannon didn't like blast through the other side of your ship. That make sense? When I was in high school, I distinctly remember a physics question my teacher asked me about. It was about the concept of like an astronaut in outer space. I think I maybe mentioned this to you guys. Who gets farther and further away from his ship. And so what he does is he takes his wrench and he throws it that way, causing his momentum to go the other way. Ever told you guys this story? Or like shown you a question like that? Now, if you were to throw something this way, kind of like the Magic School Bus episode, where the pitcher throws the ball that direction, a force is going to cause you to go the other direction. Momentum is very similar to that. If you have momentum going this way, you need some going the other way. So. Okay. What I want to do is walk you through 5 typical kinds of problems. Okay, so we're just going to do 5 examples today. I think 5. And hopefully, like, once you get examples in the future, you'll be able to figure that they're one of these 5 types. And so I've got pictures to, like, go along with all of them over the next few slides. So let me walk you through them. First example momentum question. A linear collision where objects separate. So the picture I have here is, imagine there's 2 pool balls, and someone shoots a pool ball and it hits the other pool ball. Well, the momentum from pool ball 1 will hit pool ball 2 and cause the other one to move, but the objects are going to, like, separate away from each other. Does that make sense? Linear, because it's going to be in a straight line. Another type of question is a linear collision where objects stick together. So imagine that you get rear-ended in a car crash. So car 1 is right here, car 2 is right here. The one car rear-ends the other car, but, like, they stick together and keep going forward a little bit. Does that make sense, the difference there? The pool ball example, one thing hits the other one and they bounce off each other. The other one thing hits the other one and they collectively go forward as, like, one object, all squished together. The next one is an explosion, which is really similar to the cannon example, where if the bullet goes this way, the gun itself is going to have like a recoil to it, going back the other way. Next example would be intersecting collisions. So that's where car 1 is going this way, car 2 is going this way, and they collide. Does that make sense? Okay. And last type of example, I use a curling shot for this one. It's called a glancing collision. This is where one object is stationary and then the other object hits it and bounces, like, off to the side. So, like, imagine you have a curling stone here. This one comes in and hits this one and goes that way. The curling stone will probably go that way. That makes sense? So, straight line collision where they bounce off each other. Straight line collision where they hit each other but, like, collectively move forward as a group. An explosion where things go in different directions. Collision where they intersect and hit each other like this. And then one where this guy is actually stationary and this one just bounces off of it instead. And they can't hear me, of course. Okay, bear with me for a second, guys, here. I'm just going to restart this. Can you guys hear and see me now? Can you hear me? Perfect. Okay. This is getting weird. I might have to email Curtis and see whether he knows anything. Okay, did that make sense so far then, the 5 types of examples we're going to do?
Yeah.
Okay. So let me do one of each. So, first example. Most of these, you probably are going to want to draw a diagram. Not that you need it for the actual answering of the question. You know, like, your questions are going to be multiple choice from here on out. But it wouldn't hurt to draw a diagram if one isn't clearly there for you. So, you have a white billiard ball moving 8 meters per second to the right. Let's see if I can diagram this. Billiard ball moving to the right at 8 meters per second, and it's 0.15 kilograms. Then it hits a black billiard ball with the exact same mass which was at rest. So ball 1, ball 2, ball 1 hits the one ball, and so the other ball is going to keep going probably in a straight line pastward. So the white ball then continues to move at 2.5 seconds, 2.5 meters per second. We want to figure out how fast the black billiard ball is going. So white will keep going, but black should also be moving as well. I don't know whether my question kind of makes, my diagram makes sense here, but white hits black, white keeps moving, and black keeps moving. So here's how I might set up a question like this. We've got to figure out the total momentum beforehand and make it equal to the total momentum afterwards. So what objects do I have that could have momentum? The white billiard ball and the black billiard ball. So you could almost do like the mass times the velocity of the white ball beforehand. And then you could add the mass and the velocity of the black ball beforehand. And that should equal the mass times velocity of the white ball afterwards, plus the mass times velocity of the black ball afterwards. Does that make sense? It's very similar to energy in a way. Keep track of all of your energies, keep track of all your momentums. One of these four is actually unnecessary.
The white one.
The black one to start with. Because the black one to start with wasn't actually moving. So if I really wanted to, I could probably just ignore that guy there and say, originally the white ball had momentum.
Mr. Bonnet, can you please come to the office? Mr. Bonnet, please come to the office.
So originally the white ball had momentum, but the black one was stationary. And afterwards they're both moving. And according to conservation of momentum, it should remain equal. So I know the mass of the white ball. It was 0.15 kilograms. I know how fast it was moving. It was 8 meters per second. And then afterwards, the 0.15 kilogram white ball is only moving 2.5 meters per second. The black ball was actually the same mass. Probably could have canceled mass if we wanted to. But what we don't know is his velocity. It's really similar to energy. And also kind of similar to forces in a way. You just got to keep track of them all. So, how do you get V by itself? Subtract this guy and divide by that guy, yeah. So I'm just gonna find some numbers for you here. 0.15 times 8. So this guy would have been 1.2. 0.5. Oops. 1.5 times 2.5. This guy would have been 0.375, and then 0.15 V. So just make sure I show all my steps. Minus 0.375. That's 0.825 equals 0.15 V. So I got 5.5. That makes sense? In terms of context, if the white ball was originally moving at 8 meters per second, and it moves considerably slower afterwards, it transferred almost all of its momentum to that guy. Like, it still kind of moves slightly forward, if that makes sense? So, like, stationary, this guy hits him. This guy goes flying away. This one still goes forward a little bit, but not really that fast. So the remaining amount was the 5.5. On this particular question here, since the masses were the same in every single one, you probably could have actually just canceled mass all the way through the equation. No, that would have worked. That is probably going to rarely work though, because I don't think every time the masses you're going to have are always going to be the exact same amount. But in this example here, it did work. Right. So I mean, if this is 8, this better be 2.5 and 5.5. They better add together. Okay, let's try a different example. Here's one that's more like a car getting rear-ended. You have something and something else that collide with each other, but rather than separating as they go forward, they're gonna stick together as they go forward. Okay. So this one here, we're gonna use 2 balls of clay. So the blue ball of clay was moving to the right at 12 meters per second. And the red was moving to the left at 8.1. So it's almost like they're going head-on collision, but the thing is going to probably move one way or the other. Like, it's not going to come to a dead-on stop. What else can I do here? This one's 2.3 kilograms. This one is 5.6 kilograms. So this is kind of before. Afterwards, red and blue are going to be like stuck together. And they're either going to move this way or this way, depending on which one has more momentum. It's kind of tricky to figure out though, because this one here is moving 12 meters per second. And this one's 8.1, so you might think it's probably going to go that way. But this one's heavier, and this one's lighter. So we'll figure it out based on like positives and negatives by the time we're done. So let's see. Momentum before. We'll need to equal the momentum afterwards. So who do we have for momentum before? Well, we have the blue one. So I can do mass times velocity for the blue one. And then the red one, I can do mass times velocity for that one. What about afterwards, though? Are they still separate? So why don't I call them red? Blue-red. They're stuck together now. Sure, let's go with that. That makes more sense. It's more clever than what I said. Okay, so the mass of the blue one plus the mass of the red one is going to have to equal the mass of the purple one because blue and red mix together now. So, one more thing I got to do. I got to figure out which way is going to be positive and negative. So why don't I go with the blue being positive and then the red being negative. So like it wouldn't hurt just to make sure that I know that that's positive and that's negative. Does that make sense? Because we have to keep track of directions. So, okay, so 2.3 gets multiplied by 12. And then we're going to add 5.6, which gets multiplied by negative 8.1. What do I do for the mass of the purple one? Perfect, add them together. So if it was 5.6 and 2.3, that adds up to 7.9 times the velocity. So 2.3 times 12. I'm just going to do it really step by step. I got 27.6. And on this one I got negative 45.36. Which one of these two things had more momentum then? The red one or the blue one? Yeah, the red one, right? When I times these two numbers together, it's 27. Even though this one was going slower, it had enough of a mass that the red one actually had more momentum. Meaning like the red one is going to win this collision. It's going to go backwards the other way. So 27.6 minus 45.36 divided by 7.9. I put a little note here. 8.1 is negative due to backwards. Don't forget that. Like that's huge on this, right? Keeping track of which direction it goes. I got 2.25. Which I'm thinking I screwed up sig digs. I only get 2 sig digs. So 2.2. I have 2.248 myself. So the 4 would have rounded up to a 5, but not the 2 up to a 3. Thanks, Heather. Okay. So either put it like I would just say 2.2 meters per second left, just to make sure you know which way it is. I need to. Hey, what's up? Was it Burdette? Yeah, she emailed me and I got back to her. Cool. Okay, bye. Okay, so a couple of thoughts on that one. Make sure you put the negative, positive, like right off the bat so you know which way is which. They could then answer that this was going negative 2.2 meters per second right, or positive 2.2 meters per second left. Either way, the red one is going to kind of win out. So when you're done, this guy collides, but they ultimately go that way when they're stuck together because this one has more momentum to it. Does that make sense? Okay. Okay, next example. This is going to be an example of an explosion type question. We're going to fire a bullet from a gun. We actually had a question kind of similar to this on one of your assignments, only rather than it being about velocity, I think it was the acceleration of the recoil of the gun. So let me see if I can draw this. Before you start, you have a gun. Let's see if I can draw a reasonable gun. And there's a bullet in the chamber. Is that a decent gun? Alright, so gun plus bullet. Okay. When we're done, after this is over, so if I just do a quick after picture, you're going to have the gun. Probably the gun is going to kick back this way. Hopefully that makes sense. So I can redraw my gun. So the gun is here, and now the bullet is out here. So the bullet will then be going this way, and the gun will kick back the other way. Does that make sense? Let me throw some numbers in here. The bullet is going to be 0.050 kilograms, whereas the gun is 5.0 kilograms. And the bullet is going 275 meters per second. I'm going to do the same thing I did last time. I need to make sure I dictate which way is positive and negative. So I think it makes a lot of sense to make this way be positive and that way be negative, just to keep track of things. Okay, so let's do the same thing we just did the last few questions. Your momentum before will have to equal your momentum after. What did you have before? It's at rest. So I mean, I guess technically before you had the gun plus the bullet all together. So like your mass could have been, like your mass would have been 5 plus 0.05. But your velocity was 0. Yeah. So beforehand, really, your momentum was nothing. Before you started, you had no momentum whatsoever. Afterwards, you should have a mass and velocity of a gun plus a mass times the velocity of a bullet. Okay, so mass of gun, 5 kilograms. Velocity of gun, unknown. Mass of bullet, 0.050 kilograms. Velocity of bullet, positive 275. To solve, throw that guy to the other side, divide by 5. Your velocity is going to be negative. Does that make sense? Yeah. So you're going to have negative 5.0 V equals, what's this going to be? 0.050 times by 275. So 1375. So divide by negative 5, divide by negative 5. What was that? Because this 5 you had to bring it to the other side and make it negative 5v. Or I guess you could take this thing right here and bring it to the side and make it negative. It doesn't. Okay. Either way, you get a negative though. So, how many sig digs do you get? 2. So I have negative 275. So that'll be negative 2.8 meters per second. Or probably the better way of putting it is 2.8 meters per second. Did I say direction? Yeah, backwards is probably the best way of putting it. What am I doing? Is this pretty straightforward?
You wouldn't put the negative on it now because you said it's going backwards.
Yeah. So like if you said it was going backwards and you threw a negative on it, then that would kind of be like a double negative kind of thing, and that means it'd be going forwards. Does that make sense? Okay, why don't you guys take a 5-minute break right now, because the last 2 examples are the hardest ones, because they're going to start becoming in 2 dimensions. So let's take a break now. Because the last 2 are going to be the ones, like you might have noticed, I've left 3 blank slides for you to work on, because I'm expecting there to be a lot of work. Just on the pile right there is good, Jack. Thank you. It's like, there's one pile, Jack. There's one pile. Sorry, for which one? You didn't write it? Oh, okay. What do you want to write it? Like you're talking the energy test. Okay. One works best for you. I gotta print one off. I think I recycled them all. I didn't realize you didn't write it.
Do you have a math test today or the bio test today?
I think you have a math test today and a bio test tomorrow.
Yeah.
You want to go on like Wednesday or Thursday?
Oh yeah, Wednesday I have social because I can come after if you want.
It doesn't matter to me. We just need to get it done before the end of the semester, just so you can have energy mark finished off. If you want to do it Thursday, that's fine with me. Because it'll just take you an hour and a half or so, and then you can mark it real quick. So just let me know when you want to. Yeah, this week for you guys is kind of like test week, eh? But it's all you have for like the next 6 days. It's tests. Well, that's why I'm really glad that I didn't give you guys like a physics test to work on, because I would have just added to the problems, right? It's like math today, bio tomorrow, social the next day, day off, bio, math. Yeah. So like at least for today and tomorrow are the last day of classes. So then after Wednesday you're good. We'll still be open, yeah. So if you want to come, like, you know, in the afternoon, I'm thinking for some of the grade 12s, like on Wednesday. You know, if you're here anyways, writing your social diploma, if you want to study in my room in the afternoon, you're more than welcome to. Like, your attendance is not required, but if you want to come, I'll be here. So. What's up? Oh, you've never done one of these before. Okay, so when you're finished, the percentages right here, you're allowed to in this unit get rid of one of your worst marks. So for you, that's just the 62. So what we'll do is like take the 75 and the 72, and then the unit test, you always have to count more.
Okay.
How much more depends on how well it goes and how big the unit is. So the rule I said for this unit is either 2 or 3 times. You did well, so we'll count it 3 times. So 92, 92, 92. And then when you're done, then since there's 5 things there now, divide it all by 5. So 85. Does that make sense? So then on the back page, usually what I'm asking for then is for your final unit grade, you'd kind of more or less write what I did there, where you'd say like 75 plus 72 plus 92 times 3, all divided by 5. Maybe even make just a note like I'm omitting the assignment. Does that make sense?
And do I
Just put something there.
assignment in the folder?
Yeah, so include everything that were there, because when we go for the progress log is if I need to hand it back to you for like study purposes, then you've got everything there. And then the other thing I ask for is if you can, just think of some things that like either you're good at or something you need to work on, or like even on individual assignments, you know, just some things that you can improve on. Does that make sense? Cool. Alright, do we have everybody back? That's Nicole. I'll just see what she's on. Alright. Okay, we're going to do 2 last examples. These ones are the ones that I'm expecting you're going to get on a diploma. They don't typically give probably every question in like a flat plane. What we're going to do here is have things go off at different angles in like 2 dimensions. Technically, in real life, you could probably do things in 3 dimensions, but we're only going to stick with 2 dimensions. So this is going to feel really similar to like one of our first couple units, where like I'm going to give you things like east 23 north, and you're going to have to figure out angles of things. Does that make sense? So we're going to have to figure out momentum in an x direction and a y direction before and afterwards, and make sure that all of that momentum gets conserved. Does that make sense? So let me walk you through one. This one I actually gave a diagram here because I copied this from somewhere. You've got a, this is the glancing collision, by the way. You've got a red ball that is moving, and it is going to hit the blue ball. So the blue ball is stationary. And then after you're done, the red ball will go up at an angle, and the blue ball will go down at an angle, and the question is what velocity will it have? Make sense? Okay. You got to keep things organized. So beforehand, you've got the mass and velocity of the red ball in the x direction plus the mass and velocity of the blue ball in the x direction should equal the red ball's x direction mass velocity. No, because all of the x momentum will have to maintain the same, and all of the y momentum will have to maintain the same. Yeah, that's what's going to make this question tough, is that you're going to have to almost do it twice, one for each dimension. And then blue, x, mass times velocity. Okay. Perfect, yeah, so you're saying this one right here? Yeah, we don't actually have any momentum for the blue one, so that one's out. Okay, so I can fill in the red one first. The mass of the red ball was 120. Lisa, could you grab that door again, please? Sorry. Times 17.1. Now, we know the mass of the red ball is still 120, but I can't plug in 13.5. Because the 13.5 is actually the hypotenuse. Right? And so this might look similar to what we've done in previous units. We have to figure out the x and y components of this. So if you guys remember how to do that, this will be like sine because it's opposite. So this will be like sine 23 times 13.5. Oh, sorry, I did y first. And then for x, we'll have to do cosine 23 times 13.5. Sorry guys, let me just write it off to the side here. Red x will be sine 23 times 13.5. I'm just going to do that one because I know I'm going to need it later anyways, so I may as well find it out now. So that's 5 point... Ooh, I better make sure I'm in degrees. I'm in degrees. 5.27487. And then red y. Shoot, I screwed that up.
Yeah, just change the X.
X and y. This is y, and this is x. That'll be cosine of 23 times 13.5. It's Monday. I got 1242. 6815. Did that make sense, that breaking it up into x and y components? So then for the red ball, its velocity will actually be the x velocity, which will be the 1242.68 number. And then I'm looking for the x component of the blue ball. So blue ball was, what's its mass? 231. So I think at this point here, I'm just going to not show the algebra and assume that you guys can get v by itself. So 120 times 17.1 minus 120 times answer divided by 231. I got 242.76. 2.42. 76283. So that's the velocity. I'm going to be really specific here. Did anybody else get that, or is that just me? I made sure that when I used this 1242.68 number that I used the exact value, hopefully, of cosine 23 times 13.5. Did I make a mistake?
No, I got
You got the same thing? Let me just make sure I write this down very, very specifically. This is going to be the velocity of the blue ball in the x direction. I'm going to circle that number, but we're not done yet, though. Yeah. Yeah, if you didn't hear Heather's point there, we now have to find the y direction velocity. And then once we find the y direction velocity, we then have to make it a hypotenuse to find the actual true, and we also need an angle when we're done too. I know, there's a lot of work on this one. Does that make sense so far though? At least up to that step? Everyone's okay with getting that number of 242.76 kind of thing?
Yeah.
Okay, this next one here, I would recommend you set it up in a really organized fashion. You probably can make it easier on this particular question, but I would actually do the exact same thing then in the y direction. So I'm going to do another color here just to help separate them. I would say we need to do the red y plus the blue y equals the red y plus the blue y. Mass times velocity, mass times velocity, mass times velocity, mass times velocity. Okay, now on this particular example, this might have been redundant to actually write this all out. Because what y momentum did the red ball have? None. Yeah. And what blue momentum did it have? It doesn't. Come on in. If it's open. Hello? Good morning. Looks like yogurt, bananas, and muffins. Oh, still some apples too. Thanks, guys. I feel like most of you probably know where to go on this last step here. But if you don't, these momentums were nothing because the ball was not even moving in the y direction originally. Where is this red y velocity going to come from?
Up here.
Yeah, I wrote it way up here. I mean, I was doing the sign when I didn't need to, but the red Y was the 5.27487. So just make sure you try to hold on to all those values. 5.27487. So I'm going to go back up in my calculator if I can. Take that number, times it by 1.20, and then divide by 2.31. For my velocity, I got negative 274. Anybody else get a negative?
Yep.
Because the negative makes sense. One thing that I didn't do before I started is I didn't assign a positive and negative direction. And I actually have to do that for X and Y. In the X direction, it probably makes sense to make this positive and that negative. In the Y direction, why don't I go with positive and negative? So the negative just means that the ball was going down, that's all. It's not going to affect like my answer unless for some reason as a distractor they like change like the north, south, east, west kind of component to it. So so let me make sure I'm clear about this. This is the velocity of the blue ball in the Y direction.
Okay.
Now we can make a triangle. So the blue ball went this way and this way. So we actually want the hypotenuse. So like a note. That's why, does this seem familiar to like one of our first units? Like we did a ton of this. I made sure to practice it way back then so that it seems kind of familiar now. So we actually want the hypotenuse. So where are these numbers? This is 2.42. 76283. 76283. The fact that this guy is negative is really not that relevant. Just the negatives because he's going down. So 274.019233. So c squared equals a squared plus b squared. So let's see. I need that number squared plus, where's that other number? That number squared. Square root the whole thing. I got 366. We do, yeah. We also need to know this angle down here because a velocity has a it's a vector quantity, so we need that angle. So to find this angle though, the best way of doing it is inverse tan. So if you were to inverse tan the opposite number over the adjacent number, you'd get your angle. So inverse tan. Let's see which one's opposite. The 274 goes over top of the 242. I got 4846. Something along those lines.
How do you decide the use or whatever?
Okay, so we'll do that part last. I just want to make sure first everyone gets these values at least. Is everyone okay getting those numbers? Okay. So let's do sig digs last, because now it's time for sig digs. It looks to me like everything had 3 sig digs. So to answer your question then, it should be 3.66. Okay. This way over here was defined as east, I believe, and this way was north, which makes that way south. So it's going mostly east, but 48.5 degrees south. So I'd write it as this many meters per second, and then east 48.5 degrees south. Does that make sense, Carlin, for the angle there? So mostly east and then tilting down towards the south. Okay.
Why are you going mostly east? Not just
Well, okay, so like go east and then tilt down towards the south. That would get you that angle. Whereas, let's say you were solving for like an angle right here, that would be going south and tilting up towards the east. Those are the two ways of writing it. That makes sense? Okay. You guys over there have any questions? Does that able to follow? Ask before I move on. So that's no to any questions, or that's no you couldn't follow? Okay, cool. Okay, thanks. Okay, you guys are good on that one? Okay, one last example. This one's the one you're gonna hate the most. Did I leave enough room by making 3 blank slides?
Yeah.
I left enough room there. One last example. This one's even worse. Rather than it being a glancing collision, both objects beforehand are moving when they start, and both objects are going to be moving when they're done. Do you guys want to try this by yourselves, or should I walk you through? We're not there yet? Okay. Okay. You gotta stay organized. Right? Like, organization is key to something like this. At least so that you can follow it. I won't be marking written work really that much anymore. But, I mean, there's nothing worse than you're on a diploma question and you know you don't have the right answer because it's not one of the 4 choices. And you're trying to dig back through, trying to find numbers here, there, and everywhere. So, like, please try to keep organized. So. Okay, right off the bat, I feel like it may be worth my time to break everything up into the X and Y directions before I even start. So let me label this. This 1.2 kilogram red ball was moving at 10 meters per second on a hypotenuse. It struck the 2.31 kilogram ball that was moving 15. And then when they were done, this guy was 13.5, and we're looking for blue. Okay, so I'm gonna try to draw some arrows here and try not to make this too messy. This side right here is going to be the sine of 30 times 10. And this side right here is going to be the cosine of 30 times 10. Then I'm going to do colors just because I can to keep things straight. This side right here will be the sine of 40 times 15. And this side right here will be the cosine of 40 times 15. And then this guy here will be the sine of 25 times 13.5. And this guy will be the cosine of 25 times 13.5. Does that make sense what I'm doing so far? I'm just finding all the x and y components because I know I'm going to need them, so I may as well just find them first. So, here we go. Sine 25 times 13.5 makes this guy. Need more room here. Screw that up. Seven 0 5 3 4 6 4 6 5 3 3. cosine of 25 times 13.5 is 12.235 15512. Sine 30 times 10. Oh, that one's nice. That's 5. Cosine 30 times 10. 8.66. 025 4038. Sine 40 times 50 is 9.64 11.490666665. Okay, I think I found all 6. Anybody do them and disagree with me? Did you guys actually do them just to make sure I did them right? Okay, you got the same thing as me? Okay, so now that I finally have everybody's x and y velocities written down, and hopefully I've kept it organized enough that when I need those velocities I can use them. Now let's break everything up into an x and y momentum. So I don't think I need to write momentum before and afterwards, but let's just make sure we're doing either x or y. So why don't I do the momentum in the x direction first? So there is the mass times the velocity for the red one, plus the blue one. And that will equal the red mass velocity and the blue. All right. Mass of red ball was 1.20, so I can put that here, and I can put that here. Mass of blue was 231, so that can go here and here. And then I just need all the velocities in the right place. So the red velocity would have been 5. The blue velocity, oh, you're right, thank you. Good catch. It would have been the 8.66. Glad to know you guys you understand. 8.66 number. And then let's see, the blue velocity would have been the 1149 number. And then the red velocity afterwards would have been the 12235 number. And we need to find the velocity of blue. Does that make sense? So, to the best of your ability, try to use exact values everywhere, like don't round. So, if you have a calculator that allows you to go back up, you should do that. If you don't have a calculator that allows you to go back up, talk to me. I'll show you how you can store numbers in your calculator. Just because it'll help probably, right? So 1.20 times by wherever that 8.66 number is, plus 231 times by the 1149 number, minus 1.2 times the 12235 number, and then divide by 231.
There's not going to be any negatives at all, right?
Probably not in this example. It's possible, but
What?
I got a velocity that was 963. 963, 357 basically.
Did you round?
I tried to go back in my calculator and use every exact value I could. Did you get something different? Okay, let me try mine again. 1.20 times by that 866 number, plus 231 times by the 1149 number, minus 120 times by the 12. 1223 number. And then all of that gets divided by 231. I got the same thing a second time.
I got it too.
Like what I have?
Yeah, I got that.
What I do.
I got that.
Sorry, Carolyn.
Maybe that's how I feel.
You know, I think I'm gonna write that down because it's really close to me.
Okay, so let me be specific here. This is the velocity of the blue in the x direction. You guys got what I got?
I got what you got.
Okay. If I need Carlin, I'll take a look at yours later so that we can find it. Okay, if you guys are already ahead of me, keep going. Now you got to find y momentum. So I'm just, even if it's like redundant to write this all down again, like I find it's worth my time just to be organized. You don't have to answer it the same way I do, but you have to be able to keep track of numbers, right? Because there's gonna be numbers everywhere. So mass, velocity, mass, velocity, mass, velocity, mass, velocity. Yes.
I know it's kind of like ahead, but the whole east and north thing, like I don't understand that. And
Can I just do that when I get to it?
yeah.
Okay.
Each other. Slow down.
Sorry. Probably just easier to do it just do it once. I'll do a quick review on that if I need to. The masses never change. So like one of my strategies is I always throw those masses in right off the bat. Because like those are always going to be 120 and 231. Okay, let's make sure I have these in the right spots. The red velocity is going to be 5. The blue velocity is going to be 964.18. Except it has to be negative. Because the 5 is going up, and then this 964.18 is technically going down.
I feel like that doesn't change.
Actually, I feel like it's probably going to change everything.
It's gonna change everything.
Yeah. So don't forget that like we have to consider direction. So if we're making that be positive and negative, and then that has to be positive and negative, we have to make that 964 be a negative number. So if someone asked me earlier about that, on this example up here in the x direction, nothing was negative. But in the y direction though, sorry, something was actually negative. Sorry, I didn't know that you were that far ahead of me. So 964 number. And then this red one right here will be the 570 number. And we're solving for v. Alright, 120 times 5 plus... Actually, I'm just going to go subtract to make that easier. Subtract 231. And where's that 964 number up there? There it is. Oh, and... I lost you. And you got a minus 120 times the 570. And then divide by 231. I got negative 10, like almost right on the dot.
How come that 5.7 is negative 2?
What was that? This one right here?
Yeah.
Wasn't the red one going up though? The red one was going up, so the 5 is going up, and the 5.7 is going up, but the blue one is going down, and the blue one is going down. That makes sense. So I'm expecting blue to be a negative number. I got negative 10.008. That's probably enough for sig digs at this point. And that is blue y velocity. And it probably should be negative, right? Because the blue ball should be bouncing back down compared to the red one going up. Hopefully that makes logical sense.
Why? Okay, did you get that? No. Why is my number off? Not rounding correct.
Most of you guys are able to get the negative 10 number? Okay, last two steps, just like we did the last example here. Redraw your triangle. So blue is going like this way and this way. In terms of directions, I don't know if this will answer your question here, Heather, but like this is going east and then we're going south. So like when we find this angle right here, it's going to be going east, then going some angle to the south.
When I just found the angle, it was negative.
Well, did you use a negative 10?
Yeah.
Ignore the fact that it was negative 10 then, right?
Oh.
Because what you found, you remember how like in math, if we put it in the Cartesian coordinate plane, is you just found a backwards angle, that's all.
Okay.
So the negative's not really relevant when we do like a north, south, east, west. So, so hypotenuse goes c squared equals a squared plus b squared.
Yeah.
So that, well, I better put that in brackets. That squared plus, what was the other one? 963? Yeah, that guy there. I got 1389 for my hypotenuse. What do I get for sig digs? 3 sig digs? So I got 13.9 meters per second when I'm done. Does that make sense? So this one is the negative 10.008. This one was a, what was it again? 9.63. 357. So the hypotenuse is 13.9, and then I got an inverse tan opposite over, where's adjacent? Adjacent. I got 46 degrees is this angle basically, 46.1. Does that work? So final answer, 13.9 degrees going east, but then dropping down by 46.1 degrees to the south. Oh, it's horrible. Just horrible. No, you'll probably get, like my guess, and here's where I don't have enough experience because I haven't taught physics. I've only taught it once and it's been 7 years, so I can't really guess how many questions they're going to put on for each, but I'm thinking they'll probably put on like 1 or 2 questions that are like linear questions where all you have to do is like one direction, and you'll probably get like 1 question where you have to break this all up into different directions, and it's going to take you a while.
Yeah, how long do we have to take the physics diploma?
50 questions, 2.5 hours.
Do they give you that extra half an hour extension every time? or-
Well, the half-hour extension is actually on 2 hours, so it's
Oh.
2 hours to write 50 questions with the extension making it 2.5. Okay, here's some good news though. Not every question is supposed to be like a heavy-duty math question. So there's going to be quite a few theory questions as well. So, but yeah, like on a question like this, if you have to average 2.5 minutes per question, like this is probably going to take you 5,
Yeah.
right? So like some other questions are going to have to be some like pretty fast theory questions where you go, ah, that's the answer. Well, I don't know, maybe more than 5,
Okay, so you actually have 3 minutes per question
give or take.
with the half an hour.
Yeah.
Yes, they lost you.
Oh, they lost me here. Lost me again.
Oh, this is- I better
Stupid video conferencing. Okay. Questions, guys? Okay, 2 last thoughts here then. I think that was it for my notes, right? That was the last example?
Yeah.
Okay. I don't actually want you guys to do much practice on physics, not because physics isn't important, but especially grade 12s, like, you got a lot of other stuff going on. Okay. I'm going to give you guys an assignment tomorrow, though. All I ask, spend 2 hours on the assignment sometime after your exams are over, in lieu of not writing a Physics 20 test. Does that still work?
Yes.
Okay. If you really do want to work on this because you don't need to study for other tests, you could probably look some questions up in the textbook. But my goal right now is just to teach you all of this stuff beforehand. And then when we come back in February, we're probably going to do one lab, one quiz, one assignment, and one unit test. And my hope is, you guys know how we always have like that reading week in February, where we get like a week off, like 2 weeks into school. I'd like to finish the momentum unit before that. Does that make sense? So like in the 2 weeks we come back, we'll do a lab, we'll do a quiz, we'll do a unit test, we'll do an assignment. And that means we'll have ripped off one full unit well before, like in 2 weeks. Does that work? Okay, just relax for the last little bit then, unless you really want to practice something else. Can I make sure though, get your progress logs done so that I have those finished and I can give you a Physics 20 mark? Okay. Hey, so I lost you guys for the last half of the question, hey? What's the best way of doing this? You guys will have to let me know how this works here. So let me just walk through like the main steps here. Did you guys manage to get all of the numbers in purple, green, and red for the X and Y velocities? Oh, you still saw Bridget. Okay, so you're able to follow along. Let me just verbally describe this to you then. In purple, red, and green, I found all the X and Y velocities. Then the next step was I found all of the X momentums. So mass times red, mass times blue, mass times red, mass times blue, and I found the blue X momentum. One thing that happened on this one here was this negative sign. The reason why it was negative is that the red ball was initially moving like in one direction here, whereas it's going like the other direction now. Does that make sense? So we have to like make sure our directions are proper. I guess technically the way I did this actually is that this was positive and this was negative. So like red was going positive, red was going positive, blue was going negative. Oh, actually, I did make a mistake. Justin, you were suggesting that I needed to make the red one a negative number, didn't you?
Yeah.
Now that I look at this a second time here, this would have been like, if I make this a positive and this a negative, then actually this one would have been negative and this one would have been positive. That might slightly change our answer. You want to just find everybody else who just left real quick? I just realized I made a mistake. Sorry, guys.
Is the assignment already made?
No, it isn't. Guys, pull this example out one more time. I just realized I screwed up on the positives and negatives. After all of that, I still made a mistake. Okay, so for those of you guys who are still here, does this make sense? If I make red being going down a positive number, and then blue going up a negative number, then when red continues to go back up again, that would make it a negative as well, and it would make blue going down hopefully a positive. So I think I actually screwed this up quite badly. This needs to be positive, that needs to be negative, but this one here also needs to be negative. Does that make sense? How I screwed that up?
Yeah.
That's the way I denoted it. See, I said since red, I can change it if you want. Like I could make up be positive and then down be negative, which means that I'm getting pretty messy here. It is going to change everything, yes. Boy, sorry guys. So let's make this be negative because it's going down, this be positive since it's going up, and then this will be positive since it's going up. And then hopefully this will be negative because it's going down. I'm expecting that at least. So either way, I got to change some numbers now. So negative, positive, positive is how this needs to look. So that's negative now. That's positive. And that's positive. Oh boy. 1.0 times negative 5 plus 2.31 times 9, 642.
Are you using the whole numbers?
I'm going back up and finding the whole numbers. I still have in my calculator. Then I'm going to have to minus 1.2 times whatever that 570 is.
Where are you looking?
There it is. And then I'm going to divide by 2.31. So I got 4.08. That one's negative. That one's positive. That one's positive. I got a positive number actually.
Oh. So did you just change your blue?
So I made it so that the red one was going negative now,
Okay.
because red was technically going down to start.
Yeah.
And then blue I made positive because it was going up. Red I made positive because it was going up. And I solved for blue velocity, but I actually got a positive number, which is not what I expected. So this went down, this went up, this went up. I expected this to go down. What that means then is that this blue ball right here, in terms of like how much momentum it had, it must have been going so like fast and heavy that like it actually kept going. It didn't actually ricochet down. It actually kept going straight almost. And it took the red one with it. I got 4.08. No, what you got? Let me try it one more time here.
So I got like a 1.02.
Okay, let me try this again. So 1.20 times negative 5 plus 2.31 times 9.642 minus 1.2 times 5.70, and then divide by 2.31. What did you get, Carolyn? Okay, yeah, I got 4.08 now. So that's going to change everything because now it's actually not going east-south. I have to like erase all of this now. I'm going to have to redo this tomorrow since some kids took off early. Missed that. So the blue ball that was coming from the bottom side apparently was going with so much momentum that it just kept going almost on its straight line path and kind of took the red ball with it. Does that make sense? Like as I look at this diagram, this ball right here was light and was only going 10, whereas this ball here was heavy and was going 15. So this blue ball apparently didn't even bounce back down. It actually, this diagram doesn't really fit. The blue ball probably kept going up almost. And so it's like this guy went this guy went this way. The red one went up this way, and the blue one should be going up as well.
You need to change the velocity or the mass or something.
Yeah, because otherwise the blue one's just like gonna keep ripping right through, right? Ah, I lost these guys again. So, what did I get here? I got 4.08.
So you don't have to change the x, right? 'Cause the x is wrong.
Yeah, the X was fine, right? Because everything in the X direction was going that way, right? It was the Y direction that got confusing because of the up-down part to it, right? Which I definitely butchered, didn't I? So from there then, let's just see if I can answer. It'd be 4.08 squared plus 9.63 squared, all square rooted. So I got a final velocity of about 10.5. And then now this thing's actually going to be going up because this is 9.6 and this is 4.0. So inverse tan. About 23 degrees. I'll redo that at the beginning of tomorrow's class. Just because that's pretty key. I don't want people not to catch that. Whew. So I got 10.5 meters per second as the hypotenuse and 23 degrees as the angle. So I'd say north of east. If you're struggling with that, Carlin, draw it like an arrow thing. So you're going this way first, then you're going this way. So you're going east, then north. So you're going east, and then you go north by 23 degrees.
So it's like east 23 degrees north.
No, because what you have there, north 23 east, means you went north, then you went 23 degrees to the east, and it would be like 23 up there.
East 23 north.
So that means you go. No, east 23 north is the right answer.
Okay.
So, like, draw it tip to tail. Along the bottom here, you're going east, then you're going north. So, first go east, then how much north do you need to go? Well, you need to go north so that you make an angle of 23 degrees.
Okay.
Does that make sense? Okay. For you guys there, sorry, I've really butchered the end of that question. Plus, our audio and video quality is not very good. I'm going to give it 1 star. I'm going to try that one at the beginning of class tomorrow just to make sure you're clear on it. Sorry that was a mess. I'm also going to have to email Chad or Curtis because if this video keeps booting you out, that's not good. So, did that kind of make sense? Like, a little bit at least? If you're able to follow even though you lost audio? And we're lost again. Oh my goodness, this sucks. Alright, you guys, that makes sense? My negative positiveness being screwed up? Okay. Okay. What's up? Whatever works for you. I'm here. Sure, do it first thing Thursday. Like when we normally would have physics class.